At 40,000 feet, someone is closing in on a silently cruising fighter jet without being noticed. A warning tone sounds in the cockpit. Then the tone changes. Not intermittent, but continuous. This doesn't mean someone is looking at him. It means someone is holding him as a target. The Russian pilot, a major, looks at his screen. Nothing behind him. To understand how this happened, we need to go back 40 minutes. The region stretches over a vast body of water that both sides consider their own right. Boundary lines exist on the map, but not in the air. Below, an Allied task group is advancing, a destroyer, 2 escort ships, and support elements. 300 kilometers behind the task group at high altitude, an early warning and control aircraft traces a wide figure 8. The radar dome on its back rotates. It holds the air picture of the region. That picture is the eyes of the ships below. Ships cannot see beyond the horizon. The Earth is curved, but the radar wave travels straight. This is why a task group's true field of view isn't the radars on the sea, but the aircraft in the sky. And within that picture, there are 2 more points that no one can see. An American pilot with the rank of lieutenant colonel is flying an F-22 Raptor at 38,000 feet. 2 kilometers out and slightly behind is the second Raptor. The wingman is a captain. Both of their radars are silenced. They're not transmitting anything. They're only listening. This isn't a choice. It's doctrine. The Raptor isn't in this region to show something, but to see something. It's the ships below that need to be felt. The Raptor's job is to see what the ships can't, and to do it unseen. 40 minutes of silence. Then, something appears on the screen. The early warning aircraft's operator picks up a contact from the southeast sector. Altitude close to 50,000 feet, high speed, but the contact is unstable, present on one sweep, gone on the next. The operator flags it as a possible single aircraft and reports it up the chain of command. This instability isn't a coincidence. What's approaching has an airframe shaped so that, viewed head-on, it doesn't reflect back most of the radar energy. A Su-57. And since its nose is currently pointed directly at the early warning aircraft, this is the weakest profile it presents to radar. The operator can't lock onto an unstable contact. Without a lock, he can't identify it. Without identification, all he can tell the ships below is this: there's something out there, and I don't know what it is. For a task group, this is the most unsettling sentence there is. The chain of command makes a quick decision. The early warning aircraft will hang back. A large, slow, and completely visible platform doesn't advance toward an unknown contact. The identification task will go to the nearest element in the area. That means the 2 silent Raptors. The lieutenant colonel gets a rough bearing off the data link. There's a direction. There's a distance estimate. There's no identity. He banks gently, signals the wingman with a brief gesture. The pair turns silently, and the lieutenant colonel still doesn't switch on his radar. This is where the most misunderstood aspect of the Raptor comes into play. The F-22's strength isn't just that it's invisible, it's that it can see without being seen. The AN/APG-77 active electronically scanned array radar can operate in low probability of intercept modes. By spreading its transmission power and frequency, it can scan without triggering the enemy's radar warning receiver to say, "There's a radar here." But the lieutenant colonel doesn't even use this, because he doesn't need to. The Raptor's sensor fusion combines information from its own radar, passive listening systems, and the intra-flight data link between the 2 aircraft into a single picture. The pilot doesn't see raw data on his screen, he sees one processed picture. And the 2 aircraft tell each other what they've detected through a narrow, non-leaking link. This means, if one of them hears something, both of them have heard it. And there's something to hear. The Su-57 is flying with its radar on. The N-036 array is scanning ahead. This is a logical decision for the major. He's advancing over a wide, empty body of water and wants to see what's ahead. But every radar that's switched on is also a flashlight. It lights your way in the dark, but it also tells everyone where you are. The lieutenant colonel's passive receivers see that flashlight. A bearing line appears on his screen. Seconds later, the wingman's aircraft provides a second bearing. The 2 lines intersect. Now he has a position. The Russian aircraft is searching. The American aircraft has already found it. The lieutenant colonel begins to climb. He increases engine power but doesn't engage the afterburner. He doesn't need to. The F-22 is an aircraft that can cruise at supersonic speed without afterburner. In a pursuit, this means two things: less heat signature and more fuel. Both are decisive right now. The two Raptors trace a wide arc as they climb to 40,000 feet, not toward the target's front, but to get behind and above it. Meanwhile, the early warning aircraft passes new information. The contact has changed course. The Su-57 is now turned west, and to the west, 200 kilometers ahead, is the Allied task group. The sector violation is no longer disputable. It's confirmed. Below, the destroyer's operations center senses it instantly. The Su-57 isn't just an air superiority fighter. It's a platform that can carry long-range, ship-targeting ordnance in internal bays. For a ship, the hardest problem is an aircraft that comes from beyond the horizon and appears late on radar, because by the time you see that aircraft, it has usually already released its ordnance. The destroyer's defense systems raise their readiness level. Radar beams turn upward. The task group shifts into a defensive posture. But going defensive doesn't solve the problem. It only means accepting that the problem has arrived. The chain of command makes its second decision. The contact will be identified and deterred before it reaches the ships. No use of weapons, only presence, only positioning. The lieutenant colonel receives the authorization. The pair is now in the Su-57's rear upper quadrant, 30 kilometers back. Still completely silent. The major is uneasy at this point. For 8 minutes, there's been nothing on his radar, but something isn't right. He knows the early warning aircraft hasn't locked onto him. He also knows the Allied ship's defense radars have turned upward, so they've seen him. They see him, but no one is locking onto him. This isn't calm. This means someone has handed the job to someone else, and that someone else isn't on his screen. The major makes a move. He decides to stop trusting radar and check heat instead. The spherical sensor in front of his nose, the infrared search and track system, switches to scan mode. This is a logical move because stealth design can defeat radar, but no aircraft can fully cool its engine. Every machine that compresses, burns, and expels air leaves a heat trace behind. The infrared system doesn't transmit, it only looks. That means it doesn't give itself away to the other side. It's like opening your eyes in the dark. The major opens his eyes and still sees nothing. There are two reasons for this. The first is design. The F-22's two-engine exhausts aren't round, they're flat and rectangular. Instead of shooting hot gas backward in a narrow stream, it spreads across a wide surface, mixes rapidly with cold air, and the heat intensity presented to a sensor looking from behind drops significantly. The second is geometry. The lieutenant colonel has positioned himself not at the same altitude behind the Su-57, but 8,000 feet above it. The major sensor is scanning the horizon line and below, because logically that's where the threat would come from. Above is empty sky. No one looks up. The lieutenant colonel is exactly there, and he's closing the distance. The Su-57 is still heading west. The distance to the task group has dropped to 140 kilometers. Conversations in the destroyer's operations center are getting shorter. At some point, the range of that aircraft's potential ordnance will be entered. Beyond that point, there's no such thing as deterrence anymore. Only defense remains. The lieutenant colonel knows this, and he knows the most powerful thing he has isn't a missile. The most powerful thing he has is information. But information is useless if the other side doesn't notice it. What the lieutenant colonel needs to do now is carry the advantage he holds onto the major's screen, and there's only one way to do that. He switches on his radar, but not into scan mode, into single target track mode. The difference between the two changes the entire character of an encounter. In scan mode, radar sweeps a wide area. The beam keeps moving, passing over a target once per second. The other side's radar warning receiver hears this intermittently. It's unsettling, but not a threat. In single target track mode, though, the radar stops sweeping. It locks all its energy onto a single point and holds it there. It no longer roams, it stares. And there's only one reason to do that: to continuously feed uninterrupted position data to ordnance. So this mode isn't a search, it's a firing solution. The lieutenant colonel selects this mode and locks onto the Su-57. First, a warning tone sounds in the cockpit. A second later, the tone changes. Not intermittent, but continuous. A source symbol appears on the screen. Rear upper quadrant. A moment ago, there was nothing on the major screen. Now his screen is telling him this. Someone is holding you as a target and you're inside a firing solution. He goes into a defensive maneuver by reflex. He banks hard, throws the aircraft into a fast turn, pulls over the top to break the lock beam. He prepares for countermeasures. And when he completes the turn, the warning cuts out. No lock, no transmission, no contact. His screen is empty again. This conveys more than just a piece of technical information. If he got a lock, it means someone locked their radar onto him. Holding that lock means seeing the target and being within engagement range. And that lock didn't drop on its own. It was cut because the other side chose to release it. So someone locked onto him, held it, and then chose to let go. Whoever can choose to do that once can choose to do it a second time. And the second time, they might not let go. The lieutenant colonel makes his second move. He speaks in a calm voice over the unencrypted channel. He reads out the Su-57's tail number, then its altitude, speed, and heading. All the numbers are correct. The information this sentence carries isn't technical. This sentence says, I see you, you don't see me. I know who you are, and I'm already exactly where I need to be. The major doesn't respond for a moment. He's doing the math. There's at least one aircraft out there whose position he doesn't know. Probably two. The engagement geometry wasn't determined by him, but by the other side. His radar is useless. His infrared system is useless. His radar warning receiver only sounds when the other side wants it to. His fuel level is dropping and there's no support. If he approaches the task group, he'll enter the ship's defensive envelope, and there will still be something behind him that he can't see. Continuing has no tactical payoff. Continuing means going deeper into a situation whose outcome is entirely determined by someone else. The major banks his stick. The Su-57 turns hard, nose swinging east. The afterburners ignite. Two long flame trails appear behind it. The aircraft climbs and accelerates. Now its heat signature is very clear. Its radar cross-section wide. Its position known to everyone. But it no longer matters. Because it's not trying to hide anymore. It's just putting distance between them. Below, the destroyer's operations center sees the contact moving away. Defense systems gradually lower their readiness level. Radar beams return to normal. The task group, without a single shot fired, continues on the course it needs to take. Above, the two Raptors aren't giving chase. The lieutenant colonel follows the trace to the sector boundary. He doesn't close in, doesn't lock on, doesn't touch it again. He just stays there. When the Russian aircraft crosses the boundary, he banks gently and returns to his own patrol route. The wingman silently takes his position. Their radars are off again. On the early warning aircraft screen, the region is empty. On the destroyer's radar, the region is empty. And on the screen of the major who just left, the region was empty from start to finish. Yet the two aircraft had been there for 40 minutes. So how did these two aircraft actually compare? Because the outcome here doesn't stem from the Su-57 being a weak aircraft. Both platforms are in the 5th generation class, and both were designed with different philosophies. The Su-57 is, above all, a performance aircraft. It has three-dimensional thrust vectoring engines. This means exceptional control at low speed and high angle of attack. In a within visual range encounter, what the Su-57 can do is genuinely impressive. Its sensor architecture is also notable. In addition to its nose radar, it carries side-looking arrays mounted on the fuselage and wing roots, plus additional arrays operating at different wavelengths. The reason is clear. Stealth design is optimized against certain frequency ranges, and a radar using a different wavelength can challenge that optimization. So the Su-57 is the product of a search for an answer to a stealth target. The F-22, on the other hand, answers an entirely different question. In its design, radar cross-section comes first. The fuselage shape, wing body junctions, intake ducts, exhaust layout, even the angle of panel seams, all of it was determined with this goal in mind. Supercruise capability is a natural extension of this design. Being able to cruise at supersonic speed without afterburner provides an advantage in both range and heat signature. And on top of all this comes the aircraft's least known but most decisive feature: sensor fusion and data sharing between aircraft. The F-22 isn't an aircraft that fights alone, it's a network. On paper, the Su-57 is more agile. It likely offers higher acceleration and a wider maneuvering envelope. Its sensor diversity is greater. But all of this depends on one precondition: the encounter reaching within visual range or close engagement. The F-22's entire design logic is built precisely to prevent that, to never let the encounter get there in the first place. So placing the two aircraft side by side and asking which one turns better is actually the wrong question. The right question is, who decides where the encounter takes place? In this scenario, the side that made that decision never even had to test the Su-57's maneuvering capability. In this encounter, no trigger is ever pulled. No ordnance bay ever opens. Both aircraft are undamaged. Both pilots continue their mission. But one side can't go where it wanted to go. Modern air superiority was long measured by speed and maneuverability. Which aircraft climbs faster? Which one turns harder? These metrics still matter, but they're no longer first in line. Today, the decisive question is simpler: who sees first? Because whoever sees first chooses the distance. Whoever chooses the distance chooses the geometry. Whoever chooses the geometry has, to a large extent, already determined how the encounter ends. No matter how capable the other side is, they can't make a move against something they can't see. One side knew everything, the other side knew nothing. And that inequality decided the outcome without a single shot fired. If you enjoyed this, subscribe to the channel and turn on notifications. See you in the next video.